Alright, so as we look at the next example, I'm going to change the problem, so we're going to ignore this one. And we're going to have x cubed minus 3x squared minus x plus 3. We want to look on the graph of this function. So the first thing that I ask for is it increasing or decreasing? And so increasing or decreasing is determined by the leading coefficient. So since the leading coefficient is positive, our graph is going to go up. So it's increasing. Next we're going to look at the number of turns. And the number of turns is determined by the degree. So since it's 3, we take 3 minus 1 gives us 2. So at most we're going to have 2 turns. Now we're going to look at the y-intercept. And the y-intercept is determined by the constant at the end. And that's a 3, so we're going to be able to graph that. So our y-intercept is 3. This is the first point that we can actually put on our graph. Let's change color. Alright, now identify the number of real zeros. So we're going to look at our function, and since it has 4 terms, we're going to try grouping. And so as we look at x cubed minus 3x squared, what do they have in common? And so we notice that they both have an x squared, and so this becomes x minus 3. Now we look at the next 2 terms, negative x and positive 3. That looks a lot like this, except the signs are opposite. So what we can do is we can take out a negative 1, and that'll change both of our signs, so we get x minus 3. And so now, remember the important part when you group is that this and this are identical, and that's what we have, so we can continue. And so now we get x squared minus 1 and x minus 3, and so we know one of our zeros is going to be 3, but now this, we look at it and say, can we factor more? And so you should recognize that as being difference of squares, so x plus 1, x minus 1. And so our function is completely factored to this. And so now look at this, what makes this 0? So we have a negative 1, and we also have a positive 1. And so we have 3 zeros. So now we can graph those 3 zeros. Let's use red. Alright, so we have 3, negative 1, and a positive 1. So remember, our graph is going up, so over here our graph will be going up. And between the zeros, it'll make its turn. Now, unfortunately, with this pen, it's not the easiest thing to graph with, so we'll do the best we can. Let's do, I'm actually going to start down here, make my turn. I don't have enough information to decide where it actually turns at. So I don't know what the minimum or the actual maximum is, so it's just a generic sketch, but it has a little bit more detail with the zeros and the y-intercept. And so now we can look at our end behavior. So as x goes to infinity, what's our function doing? What's our polynomial doing? So as x goes to infinity, our graph is going up. So that means it's going to positive infinity. As x goes to negative infinity, what's our function doing? What's our polynomial doing? So as we go to the left, our graph is going down. So we would say negative infinity. If you want to use the other notation, as our graph goes to the left, it goes down. As our graph goes to the right, it goes up.